Okay, so this was the starting diagram for 2012. Rain is falling with a speed of 25 meters per second at an angle 20 degrees to the vertical. This car is travelling along a horizontal road into the rain. So the velocity of the car is in that direction. The windscreen of the car makes an angle 32 degrees with the vertical. The car is travelling at 20 meters per second. Okay, so I'm going to say that the velocity of the car is equal to minus 20I plus 0j. Okay, find the angle at which the rain appears to strike the windscreen. Now, the velocity of the rain, so you've got to find the angle at which the rain appears to strike the windscreen. So you want to find the velocity of the rain relative to the car first of all, and then we'll sort out the windscreen. So, the rain, here's the rain. And it tells you that if this is the vertical, the rain is falling, making an angle of 20 degrees with the vertical. So, if I was to divide that, or break that rain, we'll say, into its two components. So it would be, that's this I component and its J component. And then figure out what that is. I know that the hypotenuse is 25, so this bit here is 25. So the velocity of the rain is 25 in the positive I direction, so that's going to be 25 sine of 20 in the I direction because it's opposite the 20 degrees, and this is the adjacent side which is coming down, and that's the cos 20 in the J direction. Okay, so if I work that out, oh sorry, that's what my VR is going to be. Okay, now my VRC, this is what I'm trying to find. VRC is equal to VR minus VC. So this, if I work that fella out, 25 sine 20I, that gives me 8.55 in the I minus 23.5 in the J, that's this bit here, minus VC, which is minus 20I. So this will become plus 20, of course, so now I'll get 28.55 in the I minus 23.5J. Okay, I want to find the angle with which the rain appears to strike the windscreen. So I need to find the slope of this. So this angle here, the angle, if I call that angle alpha, the tan of alpha, the direction of this rain to the car, is 23.5 over 28.55. And when I do that, I get second function tan, I'll get an alpha of 39.5 degrees. Okay, so we're nearly there. We just have to find, so this is the angle which the rain appears to strike the car, but now I've got to take the windscreen into account. Okay, so if I just redraw what's going on, draw nice big diagrams, get your angles right. Alpha is 39.5 degrees. So here's the rain striking the car, and this is alpha. Okay, so that's the rain, that's the angle it makes, okay, with the I-axis, which means that this is also going to be alpha down here. Okay, now we have the vertical part to the windscreen, that's this bit here, and that is, this over here is 32 degrees. Okay, so I can now figure out, so I know what alpha is, I know that's 32. So let's look at this diagram now. So we have alpha. This is the angle, remember, that the windscreen makes with the vertical, so that's 32 degrees. This is my rain relative to the car coming in at an angle alpha here. Okay, and the beta, that's the angle I actually want, this one here. This is the angle at which the rain appears to strike the windscreen. So find beta, your job is to find beta. So this is the angle. Now remember, this has to be 90 degrees. So if I take alpha from 90, that will give me beta. Beta, alpha is 39.5, which means that beta is 50.5. So the angle that it strikes the windscreen, angle that it hits, would be this is your windscreen angle here now. Remember, this would be, if I extended that down, that's the angle the windscreen makes with the vertical. So the angle hits the angle that it hits the windscreen with is beta plus 32. And when I add 50.5 to 32, I shall get 82.5. And that's the angle I want at the end.